Representing quadratic functions. When we look at these are the ones where we are transferring it from one form to the other. And you always go back to standard form if it's not given to you in standard form first. And so here we have our parenthesis, and we're squaring it, so that means we're using it twice, and we're going to go on the outside and multiply our way in. So x squared, 3x, 3x, and 9. So when I combine it, I only have 1x squared, so I write it down. I combine my x's, so that's 6x, and then I have that plus 9. So that's going to go in the place of that parenthesis. X squared plus 6x plus 9. And then we have that plus 16 hanging out on the outside. The next step is going to be to distribute that negative sign to all three parts. And so when I have that, that's going to become negative x squared minus 6x minus 9 plus 16. So the negative 9 plus 16 becomes 7. And so we have negative x squared minus 6x plus 7. So that got us back to standard form. But what we need is factored form. So that means that we need to take and look for first a GCF. And our GCF is going to be negative 1 because there's a negative in front of my squared. So when I factor out that negative 1, I have x squared plus 6x minus 7. Now if I look in front of my squared, it's a 1. All I need is the x. So the product goes up at the top, negative 7x squared. At the bottom, I have 6x. Well, I can multiply to give me negative 7. That would add to give me 6. It'd be 7x and negative 1x. So when I write it again, I keep that negative 1, that GCF we factored out, and you have x plus 7 and x minus 1. So when I write my factored form, I don't have to write that 1, but I do need to write the minus sign, the negative sign in front. X plus 7, x minus 1. Now to find the other two pieces we have. The vertex comes from the vertex form. So when I do that, I look for opposite inside and the same number outside. So that's negative 3, comma, 16. When I look for my roots, I go for my factored form and I use that chart to help me solve. And so each of my factors are negative 1, x plus 7, x minus 1. And so we set each of those equal to 0. Negative 1 equals 0. Can't happen. X plus 7 equals 0. So when I move the positive 7 to the right-hand side, it becomes x equals negative 7. X minus 1 equals 0. So I move the negative 1 to the right-hand side. X is equal to positive 1. And so my roots are x equals the set, negative 7, comma, 1. And on this next one, we're given it to us in factored form. We need to take and go to vertex form. So first thing is we need to multiply these two together. X plus 9 and x plus 5, giving us x squared, 9x, 5x, and 45. Now, we can go back up here. F of x equals, we're going to take 2, and then when I take and combine this, these two are going to need to add together. We have x squared, 5 plus 9 is 14, x plus 45. So that's what's going to go in my parenthesis. And so now when I distribute that 2 to all the pieces, it becomes f of x is equal to 2x squared plus 28x plus 90. And when we go to factored form, that's when we take and are needing to find a, b, h, and k. So a is 2, b is 28, and we'll use that to help us find our hk. So the formula for h is negative b divided by 2a. And so negative b is negative 28 divided by 4 is negative 7. So that's my h. So my vertex form, that's going to be opposite of that is what's in the parentheses. Now when I plug it in to the original and to the formula, it really doesn't matter which one I plug it into. I end up with the number of negative 8. And so that's my k. And that's what's subtracted out here. This number here is a. And so my a was 2. And that's what helps us find our vertex. Opposite, same. And so negative 7, comma, negative 8. Now our roots come from what we originally had, and that's where you did the chart with each of your factors. And so this time we had 2, x plus 9, and x plus 5 as our 3 factors. 2 equals 0, can't happen. X plus 9 equals 0. So when x is equal to, move the 9 to the right, negative 9. X plus 5 is equal to 0. Move the 5 to the right. X is equal to negative 5. So my 2 roots are when x is equal to negative 9 and negative 5.